Good morning. My name is Rob Prebble from Rob Prebble Consulting Limited. I'm currently working on a few projects for forest growers research in the Automation and Robotics program. In a recent project, forest growers research undertook to determine whether a fixed felling head could reduce stem breakage during felling. Localised debris flow from severe weather events in forest catchments was the cause of significant damage to downstream properties in the Nelson and Gisborne regions during 2018. You may recall that these events made national news on several occasions. There was widespread public concern about forest harvesting practices, particularly stem breakage during felling operations. Forest Growers Research produced a work plan to quantify the effects of different felling heads on the amount of stem breakage. The objective of the project was to compare the breakage from a feller director, commonly known as a dangle head, with that of a feller buncher, better known as a fixed wrist or fixed head. The feller buncher used in this trial was a TimberPro TL765D, fitted with a KF800 Felling Head, owned by Mechanised Cable Harvesting Limited in Nelson. This 43-tonne, 255 kilowatt machine is manufactured by Rosen Developments in Australia and marketed by Komatsu Forest in New Zealand. The KF800 head has full 360-degree rotation and can tilt forward up to 90 degrees. It has a 40-inch long chainsaw bar which can rotate out 180 degrees to enable scarfing the trees without having to move the base machine. The head weighs 3.5 tonnes. The feller director used in the trial was Mechanised Cable Harvesting's John Deere 909 self-leveller with a Satco 630 dangle-type felling head. The study site was a block of 28-year-old radiata in Tasman Pine Forest's Wairero Forest in the Nelson area. It was a ground-based setting with an average slope of 21 degrees. Unfortunately, operational constraints prevented the observation of the dangle head actually felling the trees in the trial site. So a similar machine with a Waratah L95 felling head working in a nearby fire damage stand was used to collect activity sample data. The sticks data from the trial site was still able to be used to compare breakage. Average piece size was around 1.3 cubic metres, mean tree height was 38 metres, and the average diameter was approximately 36 centimetres. Machine utilisation was established using activity sampling at 30-second intervals. The sticks harvesting software was used to compare breakage between the two machines. A sample of trees were manually measured to verify results from the sticks analysis and to try and determine the cause of stem breakage. A total of 1,381 stems were harvested in the trial. Have a look at the following video clip and take particular note of the tree in the vertical position above the centre of the machine as it slews around, the upwards curve of the tree as it falls towards the ground, and the soft impact of the stem as it hits the ground. From the sticks data, on average, trees felled with the feller director, represented by the blue bars on this graph, broke at 22 centimetres, while trees felled with the feller buncher, shown by the orange bars, broke at 16 centimetres. This was a 27% reduction in small end diameter. Using the same colour scheme from the sticks analysis, this graph shows the average merchantable stem length for the John Deere was 16 metres, while the TimberPro was up to 22.5 metres. That is a 40% increase in merchantable volume. A small sample of stems were measured after felling but before extraction in the TimberPro trial area. Trees felled uphill broke at 89% of mean tree height, while trees felled across slope broke at 92%, and trees felled directly downhill broke at 76%. Although the sample was small, this shows that stems felled across slope and uphill were longer and broke at smaller SED than stems felled straight downhill. This slide shows a breakdown of the felling cycles for the two machines. Remember that in this instance, the John Deere in the right-hand graph was working in fire-damaged trees. You can see that 84% of the TimberPro's cycle time was spent actively felling trees. This is represented by the dark blue, red, green, purple, and light blue wedges. The remaining 16% of its time was spent clearing access to the trees and repositioning. But it should be noted that there was significant amount of wind throw in the trial area. By contrast, around 90% of the John Deere's felling cycle was spent actively felling trees, and the remaining 10% was clearing debris to gain access to them. The fixed head machine felled 70 trees per hour, whereas the dangle head felled over 100 trees, but the condition of the stand will have had some influence over this result. A closer look at the graph shows that 39% of the fixed head cycle was spent felling and slewing with the tree vertical, the blue and red wedges. Compare that to 26% for the dangle head. By contrast, the dangle head operator spent a quarter of his time bunching stems after felling, whereas the TimberPro operator spent just on a fifth of the time bunching. This is represented by the green wedges. Overall conclusion, the proportion of time spent on each component of the felling cycle was similar for both types of felling head, but the condition of the trees in the stand did have an influence over the elements in the felling cycle. The sticks data showed that the fixed wrist felling head definitely reduced the amount of stem breakage occurring during felling. Thank you very much. I look forward to your questions.